Hello, welcome to this video. In the last video, we saw how to calculate absolute tolerance. We used an appropriate range epsilon and set it to 10 to the power minus 15. And for our absolute tolerance to work, we had to satisfy the condition the absolute value of a minus b should be less than epsilon. We were doing fine until we saw an example by replacing 0.1 with 1 lakh point 1 and 0.3 with 3 lakhs point 3, and this gave rise and doubt to our absolute tolerance fix. In this video, we shall try working with relative tolerance and see if this will do the trick for us. Now, what is relative tolerance? This tolerance is a measure of the error relative to the size of each solution component. Here, instead of setting the tolerance with a fixed value, we shall set the value to be x% of each other. Let us work with the same example. I am assigning an anonymous function to the same variable name as equal, and I'll pass the same parameters a, b, tall, and I'll be returning the same expression math dot absolute value a minus b, and I'm checking if it's smaller than epsilon or not. Now I'm naming the variable a and I'm assigning it 0.1. Instead of me writing 0.1 twice again, I'm multiplying it with 3, and var b is equals to 0.3. I'm assigning 0.3 to the variable b. Now I'm assigning variable x the value 1 lakh point 1 right now, instead of me writing it after console logging the first solution, that is for a and b. Now var y is 3 lakh point 3. Okay, now let us assign the variable relative tolerance 0.001. We are setting the relative tolerance to be in percentage. Now here percentage becomes into 100. And now we are setting the variable tol with relative tolerance into math.max, math.absolute of a, math.absolute of b. Okay, here we are multiplying relative tolerance with the maximum value of a or b, because this is going to make sure that either one is going to be larger than the other, and in this way epsilon is always going to be greater than the absolute value of a minus b. And now we can be safe, and we are sure that the epsilon value is going to be greater than the absolute value a minus b, and the solution we are going to get is not going to vary across different numbers, and we are assigning the value to the variable tolerance. Now let me console log by calling the function as equal, and I'm passing the parameters a, b, tall. And now let us see what the answer is. If EPS is not defined, okay, sorry, this should be epsilon. Cool. Now we get the answer to be true. We got true when we passed a, b in absolute tolerance as well. Now let us try passing x, y instead of a, b. And while running it, we get the answer to be true. While we did it with absolute tolerance, the solution was false, but with relative tolerance, we got the answer to be true. Amazing, isn't it? But haha, there's a small problem in this solution. That haha was sarcastic, by the way. But there's a small problem in this solution too, and I'm leaving this to you. Find out what the problem is. I'll give you a hint. It has got to do with values closer to 0, and try combining both absolute, this one, try combining absolute, where is it? This one, absolute tolerance and relative tolerance, and apply both of them in a single function. You might get the solution. I'll see you in the next video with the solution. Thanks for watching this video. See you in the next video.